Good evening to all Sri Lankans and good afternoon to Huddersfield. I think Tushar is only there from Huddersfield. Is Tushar there? Okay. And now we are going to start the technical session 2C, disaster preparedness. Actually, I am Champa Navaratna, a senior lecturer, senior professor in Department of Agricultural Engineering, Faculty of Agriculture, University of Ruhuna. So I have my co-chair, Vatsala. Vatsala, can you introduce yourself or may I introduce you?
I can do that. Thank you, Professor. I'm Vatsala Jayamana. I'm working as a program officer for United Nations Children's Fund, or the UNICEF in Sri Lanka country office. I have my duty encompasses disaster risk reduction, climate change adaptation, and emergency response with regards to children. Thank you.
Okay, thank you, Vatsala. Now, before we start in the technical sessions, I'll just give some announcements. Actually, for all, there were scheduled 6 presentations, but last moment we came to know that one is not present in here. So now we have 5 presentations. For each presentation, we have 10 minutes for presenting and 5 minutes for questions and answers. So now myself and Vatsala, we talked each other and we decided to have this discussion Q&A answer question and answer session after 3 presentations, and thereafter another 2 presentation is there. We will have it for at the end of the all 5 presentations. Then after first 3 presentations, we will have Q&A session. Then together we have 15 minutes there for all first 3 presentations. Okay, then I think now is the one. There are no much audience here. Anyway, we will start the presentations. So the first presentation, second one in the list, development of a decision support weather advisory system for dry zone farmers in Sri Lanka. The authors are Disanayaka U, Premalal S, Vikram Singha D, Gunaratna P, and Edrisingha A, and Rinsi R, Kuruparachi N, and Hettige B. I think Ms. Disanayaka is going to present the paper. Nipuna, can you share her presentation here?
Hello everyone, I'm Vasara. On behalf of the research team, I would like to present our study on development of a decision support weather advisory system for dry zone farmers in Sri Lanka. The climate of Sri Lanka is characterized as a tropical climate. Mean annual temperature varies between 16 degrees centigrade to 27 degrees centigrade. Mean annual rainfall is between 900 millimeters in the wettest parts of the country to 5,000 millimeters in driest areas. Based on this rainfall, there are 3 climatic zones, namely wet zone, intermediate zone, and the dry zone. The agriculture sector provides employment to 25% of the labor force, contribute to the GDP 7.9%, and rice is the dominant crop, occupying 34% of the total cultivated lands in Sri Lanka. Sri Lanka has experienced extreme weather events such as floods, landslides, and droughts, which are predominantly caused by rainfall variability. Agriculture is one of the sectors that has been adversely affected by the impacts of climate change. Now, dry zone is more vulnerable to climate change as they are affected by other factors too, like land degradation, water scarcity, and heavy reliance on primary agriculture. As agricultural activities are mainly dependent on weather conditions, early warning weather forecasts are essential in order to mitigate any negative impacts and reduce the risk in agriculture. Agromet advisories provide such crucial information about agriculture and the climate that could be used in decision-making on agronomic practices. During the cultivation meetings, this information is presented. Now, against this backdrop, the aim of this study is to establish an effective and efficient integrated weather information system for farmers and local decision makers in rain-fed dry zone to enhance their disaster resilience. Methodology of this study comprised of three main stages: assessment of needs and demand for weather-related information, evaluation of the existing weather and agriculture advisory system, and findings of the stage 1 and 2 contributed for the third stage, that is, development of a solution package to deliver effective weather and agricultural advisories to farmers. Needs assessment was conducted with the main stakeholders of the proposed weather information system, that was farmers and the government sector officers, those who are responsible for disseminating weather advisories. Now, this study was confined to Kurunegala and Anuradhapura districts, and from these two districts, 136 government officers were interviewed using survey questionnaires, and around 221 farmers and officers participated in focus group discussions. During the second stage, key informant interviews were conducted with responsible officers attached to the relevant agencies in order to be familiar with institutional policies, procedures, and practices related to generation and dissemination of weather advisories. Desk reviews was conducted to study the extent of support services required to adopt advisories at the farmer level. Thirdly, site visits were conducted to assess the capacity of agrarian service centers, which are field level decision-making places, to act as local knowledge hubs. During third stage, a system architecture for an agromet advisory information system is proposed. And the proposed system was validated through consultative workshops with the respective stakeholder agencies and farmers. Now let's move on to the results and discussion. Demand for agromet advisories was determined based on the survey with government officers. Accordingly, we could see only 22% of the officers have actually received the agromet advisories regularly. Then out of these recipients, 52% of the recipients have used these agromet advisories in cultivation related decision making. And most of the officers, nearly 83%, acknowledge the usefulness of such weather information. And the graph here shows the extent of delivering these agromet advisories by the officers to the next level, that is to the farmers and farm organizations. There we found out that only 22% of the officers have actually delivered the information to the next level. The type of agromet advisories needed by the stakeholders are given here. They wish to receive information related to time, duration of rainfall, and other weather parameters. They like to receive separate advisories for different agronomic practices, from land preparation to harvesting. And this information, they would like to be received specific information for a given season. They also like to have long-term advisories to improve agriculture and advisories to minimize damages and to get ready for the future farming activities. When questioned on the type of information needed, the majority preferred to receive short-range forecasts, such as 1 to 3 days or forecasts at least up to 10 days. And this graph shows the preferred communication channels to receive agromet advisories. Now, as we see here, majority preferred to receive this information as SMS, using SMSs and television. Then we also studied the present system to disseminate agromet advisories. This is what we have at present. We can see here several organizations involved in the process of disseminating agromet advisories. For example, the Meteorology Department generates weather advisories. The Natural Resources Management Center of the Department of Agriculture is responsible to maintain the Hydro-meteorological observation network and to develop agromet advisories. The Department of Agriculture and the Provincial Departments of Agriculture would send the agromet advisories to the agriculture instructors at the agrarian service centers. A mode of the communication is through emails, SMSs, and written or printed documents. Realizing the need for a well-integrated decision support system to disseminate agromet advisories, the following model was proposed. New features of the proposed model included a centrally managed information system to store and disseminate agromet advisories, a mobile application and other ICT tools to facilitate information dissemination, and a divisional level information hub to coordinate agromet advisory dissemination. Here on this slide, you can see the ICT tools that can be used to deliver agromet advisories to the recipients. For example, seasonal advisories due to their high impact need to be disseminated using all possible sources. A mobile application that can be operated on mobile phone as well as a tablet is seen as a more practical and useful tool for the field staff. Now, because this can be used to retrieve agromet advisories as well as to input decisions made at the field level into the system while on field. Now, when we are to implement this type of an information system, there can be many challenges. For example, poor access to ICTs, poor network coverage in rural areas, low capacity to interpret advisories, inadequate ICT skills. There can be many problems. Now, these issues need to be addressed by providing training, awareness creation, and use of multiple sources to disseminate information. The study concludes that there are inefficiencies in the current system of agromet advisory management. There are gaps in the information dissemination channels, poor coordination between involved parties, and not receiving agromet advisories in timely manner is also a problem. Then there is demand for location-specific agromet advisories from the users. Finally, end users were enthusiastic to receive the weather information and early warnings using the latest ICT tools. It is necessary to conduct future studies to actually develop and implement agromet advisory information system for better agromet advisory dissemination. Thank you.
Professor, you're muted, sorry.
Yeah, I forgot to mention, thank you, Sarah, and I forgot to mention where is she from. Actually, she is from the Department of Agricultural Extension, University of Peradeniya. Thank you, Sarah, for your nice presentation. Now, actually, you can, the audience and the other presenters also, you can type your questions for Ms. Osara in the chat box. So we will get those questions after the other two presentations. Okay, thank you. Vatsala. And the next presenter, technophysiological approach to reduce drought stress of young rubber plantations in drought-prone areas, a case study in Moragala, intermediate zone of Sri Lanka, Nakandala SA, Veerasinghe KDN, Senaviratna P, and Iqbal SMM. Then Dr. Nakandala is going to present it. She is from Rubber Research Institute of Sri Lanka. Ms. Nakandala, the floor is yours now. Anupa, please share the second presentation.
Today, I am going to share with you research finding of a case study carried out on technophysiological approach to reduce drought stress of young rubber plantation in drought-prone areas. A case study was done in Mondragal district in the intermediate zone of country. Our research team was I myself, Sashika Nakandala, Professor KDN Veerasinghe, Dr. Priyani Senaviratne, and Dr. SMM Iqbal. As you all know, rubber is the second largest plantation crop in our country. Rubber is a wonder tree. It gives countless number of inert producers to mankind from birth to death. As you can see in this picture, we can produce many rubber products from every part of this wonder tree. Here you will understand production statistics. Production has been decreasing in significant level in recent years, and the consumption has been increasing during the same years. Means that there is a reasonable demand for rubber. When we look into rubber cultivation, you can see almost 85% of rubber lands are concentrated in western part of the country, but there are high tendency to expand rubber to other areas also. With that, the government has taken an action to expand rubber cultivation to non-traditional areas where the lands are abundantly available and sparsely populated in northern and intermediate zone of the country. Yes, it is good that we can expand rubber cultivation to non-traditional areas, but we should be aware that the climate conditions are suboptimal for growing rubber, especially during the nursery and immature period. In this table, you can see rainfall is far more below the required level of optimum condition, and there are high tendency for occurring dry spell extend up to 5 to 7 months. Therefore, drought is a disaster and adversely affect to the livelihood in those areas with climate change. Not only that, drought stress is one of the major factors that limit plant growth and development. In rubber, the influence of drought would be severe than any other abiotic and biotic stresses. It reduces plant growth, low rate of field establishment, longer immature period, resulting low yield and productivity. Therefore, the aim of the study was to introduce technophysiological package for rubber nurseries together with irrigation and application of salicylic acid in order to enhance plant growth performance and productivity of young rubber plants in the intermediate zone of Sri Lanka. Salicylic acid is an all-rounder. It plays a vital role in regulating defense mechanism of plants under abiotic stresses. Therefore, hypothesis developed by many researchers that physiological active concentration of salicylic acid can confer stress tolerance in plants. And they found that exogenous application of salicylic acid may have a significant effect on abiotic stresses. Therefore, we motivated much to use this chemical in rubber cultivation for the first time. So the case study was done in Mondragal district in the intermediate zone. We have selected a young budding rubber nursery at Mondragal substation. According to meteorological data collected in the selected site, you can see there are prominent dry months prevail from January to March and May to September, with less rainfall, high evaporation, high temperature, and low humidity. In methodology, different concentrations of salicylic acid were applied as soil drainage to the nursery plants and stressed by withholding irrigation. Daily irrigated plants are kept as a control plants to see the treatment effect. Measurements were taken on morphological and physiological attributes of plant as follows. Here we have taken plant diameter, leaf chlorophyll, stomatal conduction in 2-week interval. Available moisture content was measured by using theta probe device. Data were analyzed by using SAS package. Let's move to results and major findings of the study. In morphological attributes, plant stem diameter is one of the key indicators to see the treatment effect. Here you can see plant stem diameter is significantly increased in plants which are treated with 0.3 and 0.5 concentration when compared the other concentration. Means that SA-treated plants have shown enhanced growth performance under drought stress conditions. In plant physiological attributes such as chlorophyll content and stomatal conductance, these test tablets perform well under drought stress conditions. Overall results confirm that drought stress is a major disaster that affects the plant growth and development. Plants treated with salicylic acid showed improved morphological and physiological growth of plants under water stress, and dose at 0.3 and 0.5 millimole concentration mitigate drought stress comparing other concentrations. Then we incorporate this physiological innovation into irrigation technology in order to minimize the risk of drought disaster further by minimizing the net irrigation water requirement in large-scale nurseries when water is becoming limiting resource at severe droughts. Here we maintain different depletion levels in irrigation and also see the effect on different application intervals of salicylic acid application as once in 2 weeks, once a month, once in 3 months, and no application as a control. So we found that plants which are treated with salicylic acid in a monthly interval at 50% depletion level showed an enhanced growth of plants when compared to the other test levels and the time of applications. So with all findings, next we have calculated net irrigation requirement of plants with and without salicylic acid application by using hydro-meteorological calculation as follows. Here we have calculated dependable rainfall and crop evapotranspiration. With that, we can calculate the net irrigation requirement by subtracting evapotranspiration and the dependable rainfall. Then we have found that plant crop evapotranspiration get minimized with the application of salicylic acid due to its defense mechanism under drought stress conditions. Accordingly, you can see that we could minimize the net irrigation requirement of nursery plants with salicylic acid, especially during the dry months of the year. In conclusions, plant treated with salicylic acid significantly reduced the harmful effect on drought stress by improving growth of young rubber plants. Salicylic acid at 0.5 millimole concentration in monthly application improves physiological and morphological attributes of rubber seedlings to withstand soil water stress induced by 50% of soil moisture depletion level. An irrigation package has been introduced together with salicylic acid as a feasible solution to reduce net irrigation requirement to meet the drought risk in rubber nurseries. Finally, I would say we could minimize the disaster risk of drought with application of salicylic acid to protect rubber cultivation for another 100 years. Thank you for your attention.
Thank you very much, Ms. Sashika, for your wonderful presentation. The questions for Sashika, please type them in the chat box. Thank you. Let's move to the third presentation here today. Says lessons learned from implementing a training course on ecosystems resilience in changing climate for mainstreaming weather and climate information for sectoral development in 4 countries of South Asia and Southeast Asia. Jaisinghe S, Basnayaka S, Gupta N, Veerasinghe KDN, Veerasinghe B are the authors, and I think Ms. Susantha Jaisinghe is going to present it. Anupa, could you please switch on that presentation?
Thank you very much for joining and listening this presentation. I am Susantha Jaisinghe from Asian Disaster Preparedness Center, Bangkok, Thailand. Here I would like to share the lessons we have learned from an implementation series of trainings on ecosystem resilience in a changing climate for sectoral development in South Asia and Southeast Asia. Now let's learn a bit on how this training program initiated. During 2016 to 2019 period, we have implemented a project on mainstreaming weather and climate information application for agro-ecosystem resilience in a changing climate with the financial support from Asia Pacific Network and Japan. We have selected 4 target countries to implement this project, namely Nepal, Sri Lanka, Thailand, and Vietnam. We also have collaborated with University of Preparedness, Sri Lanka, from Nepal, Small Earth Nepal, from Vietnam, Sub-Institute of Hydro-meteorology and Climate Change, UNU Japan, and Indian Institute of Technology from India for implementing this project. The main objective of this project was to create the awareness and to build the capacity on how to use weather and climate information and relevant technological solutions for enhancing agro-ecosystem resilience in these target countries. We have identified 3 main research areas under this project. First one was to conduct ecosystem resilient training courses for especially government officials. However, it was open for other institutions as well. Under this research area, we have developed and published a comprehensive course workbook on agro-ecosystem resilience in the changing climate. Then conducted TOT course at national level to support long-term sustainability of the course, and we expected these national level trainers would pass their knowledge to the officials in different other levels. The second main research area was to conduct course evaluation to estimate short and long-term impacts. The third one was to publish a peer-reviewed paper on lesson learned on participant perspective on agro-ecosystem resilience in target countries, which is exactly I am presenting in this presentation. As we have identified the main research areas as conducting the training course on agro-ecosystem resilience in a changing climate under this project, actually before developing the course materials and delivering the training course, we have considered several factors for expecting better outputs. So that we have mainly considered about limited focus and limited use of agricultural techniques, limited availability of skilled trainers and officials, limited availability of relevant subject materials, and limited information exchange between environment and agriculture trainers. Course material and workbook we developed for the training course contained mainly 4 modules. Module 1 basically was on relevance of disaster and climate risk management for sustainability of social ecological systems. Module 2 mainly was on generation and application of weather and climate related information. Module 3 was on planning for vulnerability reduction and resilience building of agroecosystems. Module 4 mainly was on synthesis of learning through a scenario-based exercise for better understanding on how to use learned subject matters for real-world cases practically. Now let's see what kind of major activities we have done. Here, this picture shows the cover page of training course workbook we developed for that maybe the training course. And then maybe the pictures showing the movement of the training conduct in Vietnam on how participants actively engage during the training course. The first ever training we conduct in Vietnam. So you can see the maybe active participation of the participants. Those who like to get a maybe copy of our course workbook, they can access the given link in this slide to maybe download the course workbook. These pictures depict the moments of the training courses we conducted in Sri Lanka and Thailand. As you already know, our second main result area was to conduct the course evaluation at the end of each training course to collect a participant view about the course as well as how they apply these subject matters in their practical works. In view of this, we have collected participants' feedback based on 6 evaluation topics such as overall course evaluation, and time allocation, course organization, course delivery evaluation, like a day-wise topic, then a target audience and knowledge transfer and relevance. Mainly, responses type was like a type, scale, and short answers. Now let's see how the results of the evaluation look like. The first chart shows how each country has responded on overall course evaluation. It shows majority of participants have learned from the training as more than they expected before joining the training. Similar response can be seen for time allocation too. That is, participants have responded that the given time allocations for each session is quite enough. However, we can see some mixed responses here as individual participants' skill and understanding as different to each other. In this slide, the first figure is showing the participants' feedback on effectiveness, helpfulness, and coordination of the course. It shows above average feedback from almost all the participants. Other two graphs show result from Thailand and Nepal as a sample on the feedback of course delivery in terms of content, mode of delivery, and content of the course workbook. It shows almost all the participants has stated that satisfaction on satisfaction to highly satisfaction. Now, I would like to show you the very specific feedback we have received from the participants. They suggest to reducing the time for theoretical explanations. They also suggest to providing more practical oriented lectures, including an introduction to decision-making software and tools. Then they are suggesting to increase in the group works related assignments. Also suggest increasing time for some of the sessions, such as the cost benefit analysis, multicultural analysis, etc. And also suggesting to providing more orientation on ecosystem resilience related proposal writing. Now I would like to provide you overall conclusion of implementation of the project and the training course, which was the main activity of this project. The training courses conducted in the 4 countries provided a very unique opportunity to initiate mainstreaming ecosystem resilience into various sectors of the government as well as integrating the idea among the research community. We also realized that participants who have not previously experiences also can effectively train to integrate ecosystem resilience in their respective sectoral development plans. We also could achieve an average set of objectives in all 4 training courses, and a majority of participants have expressed the satisfaction on the course content and delivery mechanism, time allocation, and overall learning from the course. Here, I would like to mention that training course in Nepal has not been able to meet the expectation due to time management issues and lack of correct assessment of the participants of the TOT. As per the suggestions came from the participants, it is worth to share course materials prior to the course start to reduce time on theoretical aspects and devote more times in practice, seminar and group interactions. We suggest daily summary and group discussions are also important to reiterate important concept applied during each day during the course. I would like to mention that success of this training series was further strengthened by supportive interaction from newly trained members such as practitioners, facilitators, and members of the Agro-Ecosystem Management Society. Finally, I am happy to mention that this effort opened up a new avenue of collaboration for the stakeholders as ecosystem resilience in changing climate to carry out in a unified manner. Thank you so much again listening to this short presentation on the successful implementation of a series of training in 4 countries on agro-ecosystem resilience in the changing climate. So if you have any question or comments, please feel free to maybe type in the chat box. So I am happy to answer the questions as much as I can. Thank you so much.
Okay, thank you very much, Susanta, for the nice presentation. Now the time is for question and answer for all these 3. Sorry, I am muted again.
No, Professor, we can hear you clearly.
Okay, okay. Now the time is for question and answers for first 3 presentations. I think there are some questions. I also typed some questions there. The audience, could you please, this is the time for you. Please type your question here. Now Vatsala will manage this session.
Thank you, Professor. Thank you very much for all 3 presenters for very fabulous presentation of your research. We have several questions. Firstly, we'll start with the questions for Uvasara Disanayaka, Miss. First presentation. There's a question from Dr. Shiromini Jayawardena. Thank you for the excellent presentation. Do the officers understand the uncertainty of weather forecasts? Would you like to answer that question, please?
Yeah, thank you very much for the question. Actually, we did not particularly study this aspect of it, what they think of the, whether it's reliable or not. We mostly try to work with the existing system. So there we know the Met department involved in generating, weather forecasts. And when it comes to the agriculture department, they generate agromet advisories. And then passed down to the farmers through different other organizations. But having said that, this study, we conducted it as part of a development project. So I have observed that this project took some effort to aware these officers at various levels on the uncertainties of these weather forecasts. So they took some effort. They invited people from the Met department to talk to these officers, and these officers clearly explained to this field staff how they generate this, weather forecasts and all. That's it. Thank you.
Thank you. There's another question from Tushara Kamal Ratna. Was a very insightful presentation. He's appreciating. Have you assessed the feasibility of these communication platforms? Basically, the access for farmers on the communication platforms you were proposing.
To answer that question, let me share this slide. I hope you can see it.
Yes,
so these are some of the problems and challenges we have identified. Actually, when we are involved in this project, we We conducted a baseline study. We talked to different stakeholders and collected all the ideas. Then we planned this model for a new model for agromet advisory dissemination. Then we took it again to these stakeholders for their validation. So during this process, we involved with these different kinds of stakeholders. So we understood there are certain limitations when we try to implement it, like some farmers are not very clear on how to interpret these agromet advisories. So they receive these advisories at the moment through SMS based systems. It's usually written in English language, and they find it, some people find it difficult to interpret it. So there you need to provide some training and support to the farmers to understand that. Added to this problem, there were also limitations with poor access to ICTs, because we are talking about very rural setup where people actually can't access internet and all that, inadequate ICT skills and poor network coverage and other technical issues. So there were problems like that. Looking at these problems, we thought of going for, rather than going for a one single medium to disseminate information, we wanted to disseminate it using several channels. Like what you see here in this picture is these two farmers looking at a notice board. So we would like in this agromet advisory dissemination system, where field officers can take a printout of the advisory and put it on notice board so that the farmers can receive it, get this information. Thank you.
Thank you, Sarah. A small clarification on that one. So you're proposing the advisory to be in all three languages, or at least in the local languages, right?
At least in initial level, we wanted to work with Sinhalese and Tamil language, because in this development project, I said they are working in, Tamil speaking areas. So we would like it to be disseminated in both languages.
All right, thank you. So there's one final question from our session chairperson, Professor Champa Navaratna. Normally, we know that farmers do not like to listen to scientists' findings. What are the strategies that can be practiced to win farmers' acceptability of such a system?
Actually, during this study, we try to propose a system to make the current system an effective one. So we are actually proposing to work with the existing mechanisms where this Department of Agriculture and other provincial agriculture departments involved. So there's a very good, system to pass information to the farmers, and at the field level, now from this provincial level, it's going to district level, then to the agrarian service centers, and there they have this farm organizations who collectively make decisions on their cultivation practices. So actually, we did not suggest any new things, but we tried mostly to work with the existing mechanism by suggesting to have more ICT tools there to make the system more effective and efficient.
Right. Thank you, Sarah.
Thank you very much.
One last question from Professor Veera Singh, actually. He's asking, what are the problems related to generation of knowledge in short-term forecasts?
I think even at the present, currently the Met Department issues this 1 to 3 day forecasts, right? So the knowledge is there, but the only problem is this information has not reached this target group of farmers at the moment. So we try to give that information through this system.
Right. Thank you very much. Thank you for your time and efforts. Now the next question goes to Ms. Shashika. We have one question from the session chairperson, Professor Navaratna. As you know, the final production of rubber is latex. Is there any assurance that the yield of rubber production may not be affected by using SA in nurseries?
Yes, this is a novel technique that we use in irrigation.
Ms. Shashia, can you come closer towards the mic a little bit? Thank you.
As this is the novel technique that we use in rubber nurseries, the objective was to maintain the growth in the stress conditions. So with that, we could find that we can maintain the nurseries as in the normal irrigated conditions, even at the drought stress condition. So we can able to distribute good quality plants to the plantations when we are moving to non-traditional areas. With that, we can plant many good plants in the fields and get the higher growth rate from the immature plants. We can get the good yield with this novel technique.
Right, okay, thank you. Professor, any sub-questions on that one?
Can I else?
Yes, Professor Veerasimha.
Yes. I think the question raised on that there's an effect on the latex production, but actually this has been tried for the nurseries. So when the nurseries are building up in this Monragal and in the intermediate zones, there's this problem that for the nurseries. So that I don't think that it has big effect. But anyway, if you go to the physiology of the salicylic acid, that will promote the, photosynthesis and other reactions. And it will improve the drought tolerance. So that there are very many publications made by the Canadian scientists. Actually, one of my friend, Professor Tissa, late Tissa Senaratna, was my colleague who make these artificial seeds based on this salicylic acid. But so that we have tried this one for the rubber, I think it is really, acted on the rubber. Thank you, sir.
Thank you, Professor. Thank you for the clarification. We haven't received any other questions for Ms. Shashika, so thank you very much for your time. We have one question for Mr. Susantha Jayasinghe. Do we have Mr. Susantha Jayasinghe or any co-author from this research topic? Anupa? I see Dr. Vasnayaka.
Yes.
Hello, Dr. Vasnayaka.
And Professor Veerasimha is also there.
Yes, yes. So there's a question for the papers submitted by you from Mr. Tushara Kamalratna. Has any external agency has done any sort of post-evaluation of your program, the training program?
So Dr. Basnaik may answer.
Dr. Basnaik, you're on mute, sir.
So then may I answer the question?
Yes, please.
Thank you. Anyway, actually, we have not done any external evaluation, but this program has been tested in very many areas. Even I can say that this program has supported to develop a European Union project, new project, what we call as Build Resilience Tropical Agroecosystems, in cooperation with the University of Huddersfield and 3 universities in Sri Lanka. So that I think there were some, plus points and some deficiencies we found in this course module. And actually, I think this program has went a long way to get into the European Union support for the next development of the degree program. I think tomorrow, we are going to discuss on that.
Professor, you've got muted. Sorry.
So that I think tomorrow there will be a special session to discuss about that ecosystem resilience, building in tropical agro ecosystem, so that there I think we can further see that about this program developments. Thank you.
Thank you, Professor. So I have one final question to you. So what would be your recommendation going forward in retaining these capacities in the country, which you have developed, and replication of these training programs, because you've done a master trainers program within the country? Can you elaborate a bit on that?
Yes, we have done, I think, one master training program, at the same time some university, 2 or 3 university programs before we have done. So that with training programs, I think Department of Agriculture and the Agrarian Services has got quite a lot of experiences about this, how to get into agroecological with information on the climate change. So that I think even the rice farmers, actually we have developed this program using the experiences what we have got in the Vietnam and Sri Lanka. So about 3-year program with the Australian aid that we have conducted this program, so that these results have shown that is a very positive one, actually on to how to get the communities involved in research. So that, for example, in climate generating of the climate information, we have done some experiments with the farmers in Ilwala as well as in the Vietnam, and they themselves maintain the meteorological stations, and they they coordinated with the meteorological department, so that we got a good community participation experiences through this program, so that how it can be useful for the communities like that. So that is what I can say. Thank you.
All right. Thank you very much, Professor Veerasinghe. So
Vatsala?
Yes, Dr.
Sorry, this is Senaka. It was muted. Probably I was not allowed to speak earlier. So maybe organizers, they have allowed me to talk now. It was muted, but anyway, now it is unmuted. So Professor Veerasinghe has already responded and to that, the question in particular. So there is a long history about these training programs which we developed. It was funded by Australian aid, AusAid at the beginning. Professor Veerasinghe was involved. We conducted trainings in 2 countries, but later on, with the support from Asia Pacific Network, APN, so we were able to deliver these training programs in 3 other countries. So it's a kind of like, so then to answer to the question raised by one of our colleagues, so it was not by a review, it was not reviewed by person or any organization, but it was widely delivered in other countries as well. Hope this helps. Thank you.
Thank you, Dr. Basnayaka. So that concludes the Q&A for these 3 research papers presented. Now I'm handing over to Professor Navaratna for the rest of the session. Over.
Okay, thank you very much, Vatsala, for nice Q&A session. Now we have only 1 paper, because the paper 5 also. That means challenge to evacuate people in case of Nyiragongo volcano eruption. It is not available here. The recording is not available here, Anup told me. So now we are moving to the last presentation today, spatial and temporal variability of lightning activity in Sri Lanka, will be presented by Jayawardena IMSP from Department of Meteorology, Sri Lanka. Dr. Shiromani, the floor is yours.
Good evening. I'm Shiromani Jayawardena from Department of Meteorology, Sri Lanka. My co-author is Dr. Antti Makela from Finnish Meteorological Institute, Finland. Our topic today is spatial and temporal variability of lightning activity in Sri Lanka, which provides very important information for early warning as well as DRR. So this is the outline of my presentation. I'm going to talk about background, objective data and methodology, results and discussion, finally summary. Sri Lanka is one of the major lightning-prone countries in South Asia. On average, 50 lightning-related deaths occur. Previous studies, they use 100-day data from 20 meteorological stations to analyze this spatial variability of thunder activity and lightning activity in Sri Lanka. But with the complexity of the topography and geographic features in Sri Lanka, so these 20 meteorological stations are not well represent the real lightning spatial distribution in Sri Lanka. So main objective of this study is to understand the spatial temporal variability of lightning density of Sri Lanka using very high spatial resolution lightning data set. Here we use Vaisala GLD 360 very high resolution lightning location data from 2015 to 2018. First, we convert this data into point vector layer, then vector gridded layer with 2 kilometer resolution. Then we do the spatial joining of vector grids, and then we calculate hourly and monthly, seasonal, annual lightning density. Finally, we overlay this in a digital elevation model to see the influence of the topographic features on lightning activity in Sri Lanka. So this is the results. First, annual lightning strokes. We consider total flashes including cloud to ground, cloud to cloud, and cloud to air from 2015 to 2018. This is the average. So then we can see 3 hotspots. Highest one over the western slopes, western parts of the country, and another one over north central province and southeastern parts of the country. So highest lightning density we found more than 200 strokes per kilometer per year over Ruangalla Divisional Secretariat Division in Kewal district. So this is the interannual variability, year-to-year variation from 2015 to 2018. So we can see similar patterns with that 3 hotspots, but with some years, especially 2015, with this one hotspot over north central part is missing. But in 2017, it's very high density we can see over north central parts of the country. But overall, we can see that annual 3 hotspot over most of the years. So on average, 3 million strokes per year reported over Sri Lanka. But in 2015 and 2016, it is less than that on the average we found from 2015 2018. But 2017 and 2018, we found more than average lightning activity of Sri Lanka. Especially 2017, there are data missing from January and February. So this is the seasonal activity. So we can very clearly see high lightning activity over first in the monsoon, March, April, and then least activity during northeast monsoon. So overall, nearly 50% of the annual lightning activity is contributed by the first intermonsoon and followed by the second intermonsoon, which is nearly 25%. So to intermonsoon, the transition period between major monsoon season contributed 75% of lightning activity. Especially, I have to mention that during this time, our wind is very calm because there's no predominant wind flow over Sri Lanka. So the thermal surface heating is the prominent factor contributed the lightning activity, the convection associated with the surface heating. So this is the monthly variation. So we can see highest activity during month of April, then followed by May, October and March. Least activity we can found from December to February and even in month of June. So this is again monthly variation of the lightning count. So we can see nearly 30% of lightning activity comes from month of April. Some years, especially 2016, nearly 44% of lightning activity, annual lightning activities come came from month of April lightning activity. And these lightning activity we can see month of January and even July and even December. So this is the hourly lightning activity. So we can see lightning maxima around late afternoon, which is very common global feature. When we consider the Sri Lankan lightning activity, this lightning maxima during late afternoon between 3:30 to 5:30 is indicate that most lightning convective activity in Sri Lanka is associated with surface heating. When we overlay the lightning stroke density map over digital elevation model, we can clearly see the influence of topographic features over lightning activity in Sri Lanka, especially this highest peak over western foothills of Central Hills is associated with sea breeze and orography effect, as well as the southeastern foothills of Central Hills also associated with the sea breeze and orography effect. Over this north central parts, it is the sea breeze convergence from northwestern and northeastern part may play a role in high lightning activity in this region. These are the possible meteorological factors contributed to the lightning activity in Sri Lanka. Sea breeze convergence, convergence of the ambient wind and sea breeze over the lee side coastal regions, especially during major monsoon seasons, and influence of intertropical convergence zone, where the northern hemispheric wind and southern hemispheric wind meet together, and orography effect, as well as easterly waves. So this is a summary of my presentation. We use high resolution GLD 360 data from 2015 to 2018 to analyze spatial and temporal variability of lightning activity in Sri Lanka. We found highest district mean lightning densities from Kegol and Gampaha districts and Colombo district. This is from around 130 flashes per kilometer per year. On average, 3 million lightning counts per year were reported from 2015 to 2018 for over Sri Lanka. So annual lightning occurrence dominant by two intermonsoons. First intermonsoon from March to April contribute 50%, and second intermonsoon October-November contribute 25%. So least lightning activity found in northeast monsoon. So during the intermonsoon period, where we got 75% of annual lightning activity, there's no predominant wind flow over Sri Lanka. So this light wind and the daytime heating, sea breeze circulation, and orographic lifting contribute to development of clouds associated with the lightning activity. So this analysis provide a very useful reference where and when high lightning activity occurs in Sri Lanka. Especially we found 3 hotspots with higher lightning densities, especially we need to pay more attention over North Central, where we got higher lightning activity over North Central province, because this region, major paddy cultivation region, where people often work outside during daytime doing agricultural activities. So possibility of becoming lightning victim of lightning fatalities very high. Thank you very much. So I would like to acknowledge Severe Storm Warning Services for Sri Lanka project funded by Finland government for giving us this GLD 360 data. Thank you.
Okay, thank you very much, Dr. Shiromani, for very informative presentation. I learned a lot from them about lightning. So now luckily you are the only, your one is the only presentation for Q&A for the last session. the other two is not here. So let's have Q&A. Vatsala?
Thank you, Professor. Thank you, Dr. Shiromani, for a very interesting presentation. We have one question from Professor Veerasinghe. Dr. Shiromani, you confirm that highest lightning activities are falling on April evenings. This has been observed by Sri Lankans as Bakmahakunu. My question is, according to your findings, no change have been taken place due to global warming and climate change.
Yeah, thank you very much, Professor Veerasinghe. Actually, we have only 4-year data, so it's very difficult to say about climate change with this time period is limited, because actually this data is very costly because this is a pilot project. We got it free of charge, so otherwise it costs billion rupees to get this data. With this time limitation, actually we have 4 years, so we cannot say anything. But even within that 4 years, we can see some increasing trend compared to 2015 and 16, 17 and 18 have more lightning activity. But we need to know that this within this 2015 to 2018 there were major El Nino year, 2015 and 2016, and other thing is even after 2017 there was a mild La Nina year, so that this kind of like large scale climate modes may have play a role in the lightning activity. So it's very difficult to get a conclusion regarding global warming, but we can say because the most of the lightning activity occurred due to daytime heating. So with the global warming, I think we can expect more lightning activity theoretically. Thank you.
Thank
Can
you.
I just
Yes.
my question is how it coincides with the traditional knowledge now.
Yes, of course.
Yes. They were talking on the Bakmahakunu.
Yeah,
so,
yeah.
4 years data that you confirm that the traditional knowledge, they had the good traditional knowledge to understand this rather than put in a lot of money, as you said that, right?
Yeah.
What's your comments of that? Whether we can go for the traditional knowledge and get into this area, so whether are we going for more and more expensive technologies to find out?
But thing is, like, if we want to know what are the most highest lightning places where lightning activity occurs, so that kind of for that kind of conclusion we need to do research. Actually, we cannot go just from the traditional, because one person can say this is the place we can get maximum lightning, another person can say their place. So like we need some kind of scientific data to do this kind of analysis. Other than the timing is okay. Actually, April is the highest lightning activity we found. But if we consider places, because earlier actually we use 20 stations, so maximum found in the Ratnapur area, because we don't have a station in the Kegol district. So
how the urbanization can impact on this lightning?
Because maybe surface heating can one thing, because with the urbanization, more heating, there will be more heating, and especially urban heat island effects and that kind of thing. But here we need to consider the convergence of sea breeze also important, because especially the coastal orientation, some like capes and there that convergence of sea breeze occurs, but some if we consider the bay type area, there will be a divergence. So that kind of coastal orientation also play a role, where that's why we can see different hot spots in this diagram.
Thank you, Dr. Kirobani. Thank you, Professor Veerasinghe, for asking that question. I was thinking the same thing, actually. We have another 2 questions. One from the session chair, Professor Navaratna. What are your recommendations for the 3 hotspots which you have identified to minimize damages and losses for people and the property?
I think it's important to conduct awareness programs, how to, especially over this north central province where that the major agricultural activities occur, especially because they work during daytime and especially they are in the open area. So becoming a target is very easily, they can become one of the target of lightning victim. So I think awareness programs is very important. And second one is regarding the property, it's important to have lightning protection systems. But I know it's costly. So how we can provide this kind of technology with minimum cost also important. Doing research, putting more research into that type of activities.
Right, thank you. There's one more question from Ms. Anusha Varnasurya. Is there any reason for deficit of lightning activities in 2015? As we know, we had good second intermonsoon period in 2015 with El Nino.
Yeah, actually that 2015 less lightning activity occurs mainly in the month of April, because compared to, if I can share this screen, is it possible to share the screen? Probably.
Anupa, can you help her?
No, I
Yeah.
can maybe. So this is actually, so maybe we, so this is first intermonsoon. But in second intermonsoon, we can see more lightning activity. That it may be due to the El Nino year. But 2015 less lightning activity, is it because of the El Nino year? We cannot say, because even 2016 April is, we found its El Nino condition still was in the Pacific Ocean. But we can see higher lightning activity on that particular year. So this is probably we need to pay attention why that surface maybe like there may be like sea breeze convergence may not occur, especially over this region. That is one thing. Maybe ambient wind direction may be in a particular direction, so that's why we have less lightning activity over this region. Or otherwise, because we need to have this kind of lightning, the cumulonimbus cloud has to be developed, so that the vertical instability in this year, I think we need to do more research activities to find out why 2015 is less. Because month of April, if we consider month of April alone, 2015 and 2016 also El Nino conditions were prevailed during that time. So this is the initial stage of that El Nino, strong El Nino year, and this is the latter part. So that's why we have to particularly see this first intermonsoon activity on these 2 years separately. I think we have to study that.
Thank you, Dr. Shiromani. We have another question actually from Dr. Senaka Basnayaka.
Yes.
Has there been any evidence on reduction of damages due to awareness raising programs though the lightning activities have been increasing due to climate change?
In general, there are 50 on average lightning deaths in Sri Lanka, but this year maybe we found very less lightning deaths this year, maybe because of the COVID, because like in month of April, country is totally under lockdown, so people cannot go out. Maybe that may be one reason, but this year we get less, but compared to other year, actually I haven't looked into the figures, so I cannot say properly. Maybe people know what to do with the media and those things. Usually even we now we start to issue lightning warnings, so in our warning was a kind of like impact based warning, so we mention what to do during this
type of lightning events. So there might be some impact based on those, but I think I haven't seen the figures actually, so cannot say exactly that.
Thank you, Dr. Shiromani. One final, so far there's no other questions in the chat box. So one final question from me. What would be your recommendation based on your findings? What would you like to see based on your research happening in Sri Lanka with regards to lightning prevention, lightning damages prevention?
I think we have to, include these things in our curriculum. So that is because if we teach them from our school level, so we know what to do. So not only lightning, I think if we consider the whole disaster, so we have to make awareness programs as well as, so from the, if we put this into these things into the syllabus from our school syllabus, so I think that is one recommendation I am going to add here.
Thank you, Dr. Shiromani. I see that you're making the one good point that not only other scientific research, but change behavior culture should be inculcated from the childhood through curriculum, introduction in the curriculum, as well as changing behavior patterns. So thank you. That concludes the Q&A session. Over to you, Madam Chairperson.
Okay, thank you very much, Vatsala. And you have chaired the session very nice way and very fruitful way. So thank you very much for all 4 presenters for answering their questions very well. And thank you very much all audience there for asking questions to make this event very successful event. So finally, let's conclude our session here. Then we have listened 4 valuable studies, and they have presented in nice way for 2 technical session 2C, disaster preparedness. And the first one is development of decision support weather advisory system for dry zone farmers in Sri Lanka. Then techno-physiological approach to reduce drought stress of young rubber plantations in drought-prone areas, a case study in Monragala, intermediate zone of Sri Lanka. Then lesson learned from implementing a training course on ecosystem resilience in changing climate for mainstreaming weather and climate information for sectoral development of 4 countries of South Asia and Southeast Asia. Finally, spatial and temporal variability of lightning activity in Sri Lanka. Actually, all these presentations actually, as the conference organizers ask, actually, they are good for putting policies as well as put them into practice. I think many of them are practicing, and for policy development, for everything, they are in good format. So I take this opportunity to thank all presenters and for the audience and my co-chair here, actually not my co-chair, the session co-chair here, Ms. Vatsala. And thank you very much. So, let's end this session now on. Okay, thank you for everyone. Nipuna and Tushar is there. Thank you very much for supporting us. Okay, thank you very much.